We're going to start off 6.3 with really there's no warm-up at all. We're going to get right into a warm-up problem by doing some graphing. So there's nothing to start with. We're just going to get right into it and do some graphing of these quadratics. It's also going to be split up into two different parts. This is for days 1 and 2 for the graph translation theorem. And we're just going to do just half of the notes. It's fairly long, so we'll just do half of it in this part 1 video, and there'll be a part 2 for a different day. Let's start with number 1 here, and I'm going to graph 3 different equations and kind of see what they look like on this coordinate plane. And then I'm also going to put it onto Desmos and show you what it looks like on there. And you also don't have to fill in all these numbers for the table. You can do that in the calculator, or you can do it in Desmos. That works as well. So let's start with the very first one here. I'm just going to actually make this one black one. So we have y equals x squared. So that means we're going to plug in what we have here for x into here, and then just square the number. Which you could probably do this in your head and fill out the rest of this table in here. So if you have -3 and you're squaring it, so picture you're doing -3, of course, -3, squared. That just means it's -3 times -3. So it turns into a +9. So when you plug in a negative number in here and you square it, it becomes positive. So what's -2 squared? That would be -2 times -2, 4. And you keep going. -1 squared, it would be -1 times -1 is 1. 0 squared is 0. And keep going. 1 squared is 1. 2 squared is 4. 3 squared is 9. And then we're going to plot the points over here and see what it looks like. So -3 is here. That's all the way up at 9. -2 is 4. -1 is 1. All right. 0, 0. 1, 1. 2, 4. 3, 9. And we've actually had this shape before. This is has a special name to it for this. I mean, it's called a quadratic, but it also has a very special name for the graph. If you remember drawing this before, this is called a parabola. And we dealt with these things in chapter 2. I don't know if you remember, but we used to write it as y equals kx squared, and k was the constant, the constant of proportionality. I don't know if you remember that at all. Okay, so this is what we dealt with. It's called a parabola. But now we're going to do some things with it by adding some numbers into it. So I'm going to change to a different color here. And we're going to see what happens if we just take the same thing and do a +4. How does that change? So let's plug that in here and see. If we plug in -2 and square it, and then we add 4, what's that give you? -2 squared is 4, plus 4 is 8. Then you do it again. Put in -1 here. -1 squared is 1, plus 4 is 5. Plug in 0. That'd be 0 plus 4, which is 4. Plug in 1. It'd be 1 plus 4, which is 5. And plug in 2, you get 4 plus 4, which is 8. Maybe you see a little pattern going on here. So it's pretty important that we put this in different colors so that way you can see kind of where they cross here. So -2 is 8. Put a dot there. -1 is 5. Put a dot there. 0 is 4. And 1 is 5. 2 is back up to 8. Okay, so see if I can draw this as best I can here. Go like this. Here we go. So you should notice kind of what happened when we put a +4 at the end. How does that change things? What happened to this graph? The original graph is the black one. We put a +4. What happened to it? Hopefully you noticed that it shifted up. Specifically, it shifted up from this 0, 0. It moved it all the way up to 4, 0, 4, because we added 4. So what do you think is going to happen if we do a subtraction by 4? If I change the color again, what if we do -4? What happens? Maybe instead of taking this graph and moving it up here, maybe it will move down here somewhere. So let's see. Now I'm going to put in these numbers, square them, and subtract 4. So for instance, we have -3 squared minus 4. So this equals 9 minus 4, which is 5. Do it again. -2 squared. That's 4 minus 4, 0. -1 squared is 1 minus 4 is -3. 0 goes in there. You get just -4. 1 squared is 1 minus 4, -3. 2 squared is 4 minus 4 is 0. 3 squared is 9 minus 4 is 5. See the pattern here? From the middle outwards, they have the same answers. Hopefully you can see that. Then we'll plot the points. So -3, 5. Here. -2, 0. -1, -3. 0, -4. 1, -3. And 3, whoops, 2, 0. 3 is 5. Here we go. Okay. And I can probably connect these here. Something like this. So what happened this time? We had the original graph, our black one, the x squared, and now we subtracted 4. So it took this graph and it shifted it down the y-axis, down to -4. That's where the very bottom hits. So what is different about the graphs? And then you have to explain your thinking. I am not going to answer that. You guys can answer that. Write it out. What's different between all three graphs? How is it moving? How is it shifting? I'm not going to write it out, but specifically we're looking at something that's going, when we add or subtract a number, it's either moving the graph up or it's moving the graph down. So what I will say is it's giving us a vertical shift. When you add 4, it goes up 4. When you subtract 4, it goes down 4. Okay, we're going to do another set. Back to the black one. So again, we're going to start with this is we call this the parent graph. We're going to go back to this. I'm going to fill in the numbers again and just graph it real quick. So we already had these numbers filled in. 9, 4, 1, 0. Just copying it down. And then 1, 4, 9. There we go. Then we're going to plot the points and graph it. 1 is 1. 2 is 4. And 3 is 9. There we go. So this is like the original, like we had last time. Original black one. Now we're going to see, well, what happens if we change the numbers inside a set of parentheses and have this squared sitting on the outside. So before we had it sitting out here, right? We had +4. And it was just x squared. But now what if we throw that number inside a set of parentheses? See what happens to that. So we're going to plug in some numbers here. What if we plug in -7? So I'll write this one out. -7 plus 4 squared. That means it should be negative 3, right? Negative 3 squared, and that gives us 9. Plug in negative 6. Negative 6 minus plus 4 is negative 2. Square that, you get 4. And you can keep going. Negative 5, you get, add 4 to that, it's negative 1 squared is 1. Negative 4 makes that whole thing 0. 0 squared is 0. And then we'll get the same answers on the other side. Negative 3 gives you 1 squared, which is 1. Negative 2 gives you 2 squared, which is 4. And you can go ahead and go through this. I'm just going to go a little faster through it. This also gives you 9. So let's plot this one in red. We have negative 7 all the way out here. I specifically chose these numbers because we're going to get a weird graph here. Negative 7 and 9. Right there. Right? Yeah. Negative 6 is 4. Negative 5 is 1. Negative 4 is 0. Here we go. And negative 3 is 1. Negative 2 is 4. Negative 1 is 9. Let's connect the dots here. Here we go. Perfect. So notice what happened this time from the original graph, the original parent graph. It has now moved not up or down, but in this case, we're moving this graph all the way to the left. So it is kind of weird. We put a plus 4 in here inside the parentheses, but it moved it to the left to the negative 4. Interesting, something we're going to have to remember. So what will happen if we change our colors to blue, and what if we put a minus 4 inside there instead? What's going to happen? Let's find out. What if we put a 1 in here? Do 1 minus 4 squared. So I'm putting this number in here. That is a negative 3 squared. Ah, we got this answer before. It's 9. So it goes in here. Plug in a 2. 2 minus 4 is negative 2. Square is 4. This might look like a pattern here. Plug in 3. 3 minus 4 is negative 1 squared is 1. Plug in 4. You get 0 squared, which is 0. And the same thing going the other way. 5 minus 4 is 1. Squared is 1. 6 minus 4 is 2. Squared is 4. And 7 minus 4 is 3 squared, which is 9. So now we're plugging these in and getting the same answers, but now we're just over here on the right. So it's 1, 9. 2, 4. 3 is 1. 4 is 0. 5 is 1. 6 is 4. 7 is 9. There we go. Let's see what this looks like. Oh, I missed that dot. Something like this. So what happened this time? Let's answer the question here. What is different about these graphs? So the original one starts right in the center, like we knew was going to happen, x squared. And then when we put a plus 4 in there, it shifts it to the left, which is kind of weird. It's backwards from what you would think. And when you put a minus 4 in there, it actually goes to the right. So this actually gives us a horizontal shift. But the biggest thing is it's backwards, right? You think it's going to go one way and it actually goes the other. So it's very important to remember this. Whenever you have something inside these parentheses, it actually is backwards from what you would think. Plus 4 actually means minus 4. And minus 4 actually means plus 4. That's only what's in parentheses. Now, when we go back here, we had a vertical shift. Whatever was on the outside, no parentheses here, plus 4, minus 4, that actually meant you went the right way. Plus 4 means you go up 4. Minus 4 means you go down 4. But it is a little different when you have something in parentheses. We have one last set to do. And now I'm going to combine both of those things and see what happens. I'm actually going to put these into Desmos, and we're going to graph them that way. So the first thing I want to do, we don't have a parent one anymore this time. So I'm just going to put this directly into Desmos. I'm going to do 1 point just to show you how it works. It's not too bad. So you should be able to look at this and see how's this going to look compared to the original graph that we have starting at the center. This should be a shift here, tells you a shift of 2 to the right. Remember, this is your horizontal shift. And this should give you a shift of 1, and that actually goes up. So this should be going 2 to the right from the center point, and this should go up 1. Think about shifting that graph from the center. So if I plug in -1, it would be -1 minus 2 squared plus 1. -1 minus 2 is -3. Square is 9, plus 1 is 10. This is -1, 10. And you can keep going. I'm going to put this in Desmos to show you what it looks like. I'm going to type it in there. Y equals, I already forget what it is, x minus 2 squared plus 1. Okay, so parenthesis, x minus 2, parenthesis. And then to get this squared, you do shift 6, 2, hit the arrow over. Was it plus 1? Plus 1. Here we go. You can kind of see it here. Yeah, that's it. And if you want to bring up a table on here, you can hit this little gear here, the edit list. Click on convert to table. All right, so I have 0, 1, and 2. I still have some more numbers to put in here, so I'm going to hit enter on these ones. There's all of them, and they highlight them on here for you. So I'm going to go ahead and fill those in. So we have 5, 2, 1, 2, 5, 10. 5, 2, 1, 2, 5, 10. I think that's what it was. Yep. Then I'm just going to graph it. -1 is 10, 0 is 5, 1 is 2, 2 is 1, 3 is 2, 4 is 5, and 5 is 10. There we go. This is in 2 parts because it takes a long time to do this graphing. I'm going to change colors, and you should be able to see that it actually moved over what we say was going to happen, over 2 and up 1. So it went over 2 and then up to the 1 here. That's where our new center point is. Exactly what we said. So what's going to happen with the next one? We have a +4, which means it's the opposite of what you think. It's going to go to the left 4. And then this one goes in the right direction, vertically down 2. So let's see what it looks like. X plus 4 squared minus 2. So I'm going to back out of this. Actually, I'll keep the table open, I think. I'm going to hit plus a new expression. Y equals parenthesis x. Was it plus 4? Plus 4 squared plus 2 minus 2. Okay. So you'll see this go down. Minus 2. Here we go. And so this one moved over to left 4, down to the -2. Again, you can do the gear on this, I believe. Yep. And get some of your numbers. We're going to do -6. Oh boy. So I'm going to do that. -6. I have to type them in myself. -5, -4, 3, 2, -1, 0. Is that it? Oh, I didn't have to go that far at all. So I need -7 as well. I'll put that down here. -7. So the top number is 7. So negative 7 is 7. And then we have 2, negative 1, negative 2. What else? Negative 1, 2, and 7. Then we plot these ones. Negative 7 is 7 here. There we go. Negative 6 is 2. Negative 5 is negative 1. So it comes down here now. Negative 4 is negative 2. Negative 3 is negative 1. Negative 2 is 2. And negative 1 is 7. Okay, then we go something like this. Now we have one more to do. This should also look familiar. We said we was going to go over to the left 4, and it should go down to 2. So that is the shift that we're doing here. So we do a horizontal, then our vertical, left and right, and then up and down. Okay, last one we're going to do in blue. I'll plug these numbers in. Maybe that'll be a little faster. But you can see that they should be the same thing here. Right, we see the same shifts on Desmos. Okay, so let's plug in 1. 1 minus 3 squared plus 3. 1 minus 3 is negative 2. Square that and add 3. So that'd be 4 plus 3, 7. I'm going to fill these in real quick. This would be 2 minus 3 is negative 1. Squared is 1. That'd be 4. 3 minus 3 is 0. Squared is 0. Plus 3 is 3. Plug in 4, you get 1 squared is 1 plus 3 is 4. Plug in 5, you get 2 squared, which is 4 plus 3 is 7. So not many points here. We have 1, 7. 2 is 4. 3 is 3. 4 is back up to 4. Come on. Hate that thing. And then 5 is 7. Make our little parabola here. There we go. So this has now gone over to the right 3, which is what we thought was going to happen. If you look at this, minus 3 means go to the right 3. So here's 3. And then you go up to 3 as well. Up 3. So here you can describe what's different about the graphs. So this one actually contains both things. We have both horizontal and vertical shifts. Got them both. Now it looks like it's all over the place. We got all the kinds of things going on. So what we're doing is we have the same basic shape of the graph. We still have a parabola, but now we're moving it left and right and up and down at the same time. It looks complicated, but really at the core of it, it's not that bad. It's just moving it and shifting it one way or the other. So now we can finally get into the actual lesson. Don't worry, we're actually pretty close to being done. I'm only going to do, I think, like the next 2 slides, and we'll be done here. So how do parabolas shift on the graph? That's what we're doing. So let's talk through this, some vocab that goes with it. So that middle part that we were talking about here, it's called the vertex. So that can be your highest point or your lowest point on the graph. It depends if the graph opens upwards or downwards. So we've seen ones that go open up like this or open down like this. They either have the U shape or the N shape. We've seen both of these. Today we have not seen the N shape here, where it's shaped pointing down. But both of these are called the vertex. It's that lowest point or the highest point here. Vertex form. So that's what we've been dealing with the very last 3 set of problems that we just did. It's called vertex form. And this is what it looks like. We have y equals a times, in parentheses, x minus h squared plus k. So let's unpack some of this. A, we have not talked about much, putting a number out front. That just actually changes the size of it. I'll say size for A. We haven't messed with that yet. It can also show you whether it points up or down. So the A value out here, whether it's positive or negative, will give you different values over here at the vertex, whether it's going to be pointing upwards like this or downwards like that. This H inside here, changing that gives you your horizontal shift. Remember we said that's horizontal shift. And the K, if there's a number on the outside, that gives you your vertical shift. And then if you were to extract H and K, remember H is a negative here. If you change that sign, make it HK, HK is called the vertex. So it actually gives you this point here in the middle here, right here and right here. The last thing we have to talk about here on this slide is the axis of symmetry. The axis of symmetry is just a line that you draw, this dotted line here. It goes right down the middle, right through the vertex. It's called the axis of symmetry. So it's a vertical line going through the vertex, and the answer is represented by x equals h. So this vertical line here, if I say, what's the axis of symmetry? You would say x equals h, and the h comes from right here. So whatever's inside here, we don't need minus h, we just need h. As we do more of part 2 of this video, it'll make more sense, I think. All right, last thing, and then I'm going to show you a website that you can mess with this kind of standard form, or the vertex form. Everything here is also labeled for you. You have x equals 0. Here's the axis of symmetry here. Here you have x equals h. We have a minimum value, a maximum value. So that's the next thing we have to talk about, a minimum and maximum. So if you have this blue shape here, right, it's like that U shape, it has something called a minimum value, which means it never goes lower than this point right here, right? It keeps going lower, 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 then it stops, turns around, and goes back up. So that's called a minimum. So that's the lowest point on the graph. This only happens if that A value out front here, which I'll put here, this A value, if that is bigger than 0, in other words, it's positive, if it's positive, then we say that the vertex is a minimum. As an example, if I had something very simple like y equals 2x squared, because that number is positive, it's going to look like this U shape, and the vertex is a minimum here. Now, on the other hand, how do you get a maximum? That is the highest point on the graph, and that's only if a is less than 0. So if you get a negative number. So if I just had a graph like y equals negative 2x squared, right, that front number is negative, that changes the shape to something like this. Very poor graph, but this now has a maximum point. That's the highest point it goes to. This would be the example of y equals negative 2x squared. So that's whenever the vertex is a maximum. All right, I'm going to wrap this up, part 1 of the video, by showing you this website, which you could copy down and explore yourself. I think I might just post this on Teams as well. So if you go to this website, it will give you the graph in this form, and you can mess with some of the numbers here, which I will. And we'll stop there and we'll mess with this the next video, for example 1. So let's go ahead and go to that website. I opened it up here. This is what it looks like when you first open it up. I don't know if I can do full screen. Okay, maybe you can see that a little better. So see how it's in this form here? Ax minus h squared plus k. It's the same form we talked about. Here it gives you the actual equation. I'm going to snap these to 0. Click 0 on these two here. So right now we're looking at y equals 2x squared. Rest of it's 0. You can actually move these sliders up and down and change it. I think we've been to the site before. So I'm going to show you what it looks like if we change that a value, which we've done this before too. What if I change the a from a 2 to a -2? Watch what happens. We've done this before. Remember we talked about this getting like fat and skinny? So here's a -2. So this changes how skinny, how fat it is. I would recommend messing with this so you can understand what's going on. So let's just put it as a nice, we'll put it down to 1x squared. Then let's see what happens if we change the h value. So what if we go and change it to a -1? What happens? It moves to the right. You can keep increasing this here, -2, -3, -4. It keeps going to the right. Then if we go into the positive direction, it moves to the left. Let's see what else I have. I'm also going to display the vertex. If you hit options and hit vertex, you can do that. And you can also display the axis symmetry down here. So it'll give you all those things. So as we move this around, it gives you the vertex. Axis symmetry is down here. It's hard to see though. Move this around. If I go back to 0, you can change this last slider. This will do your vertical shift. So if you go positive, it goes up, moves the graph up. If you go negative, it moves the graph down. I would highly recommend messing with this a little bit and understanding what's going on. I can also let's do snap to integers. Maybe it's a little bit better so you can see the integer numbers. So you can move positive on the outside is your up and down. Here is your left to right. And then the a value up front, you can mess with that. That makes it skinny or it makes it really wide. And then if you go into the negative portion, it'll be pointing down. Here's your maximum values because you have a -a, and here's your minimum values because you have a +a. So again, I would mess with this site a little bit and know exactly what's going on with the shifts because you're going to have to do this by hand, graphing them and knowing what happens. So when you see this equation here, can you graph this by hand and know what it looks like, no matter what I give you? And that'll be all for this video. And then part 2, we'll continue the rest of the notes, starting with example 1.